Hello, hello. Welcome, Abhinav and Shazeb. If you want to go ahead and introduce yourselves, everyone, that would be great.
Hello, hello, hello. My name is Apna Hunt, and I am a product management lead on the Amazon Aurora team.
Hey, my name is Shazib Farouk, and I am a product manager on DynamoDB.
Guys, hey, welcome to the show. Cool, excited to have you. So today we're going to be talking about, what are we going to be talking about today?
Zero ETL, what you were just confused about a few minutes back.
Okay, so alleviate our confusion here. What do we mean when we say zero ETL here at AWS?
So zero ETL is a strategic vision which AWS is working on across the board. And it essentially takes away the overhead for some of our data management folks on the call by removing the need for building and maintaining complex data pipelines. And it helps you do personalization. So if Fiona loves a certain color of car, you could have that data stored in one database, but then you could analyze it in one of the data lakes to say, hey, Fiona loves red colored car. And that helps very easy, or that makes it very easy for all the data management folks.
Yeah, so we say ETL, just to break this down a little bit even more, extract, transform, and load. These are things that you typically do with data to get it from one source to a different destination, and it needs to be reflected in a certain format in that destination. So how do you change it and move it along? And you're saying at AWS, we want to get to a place where we don't have to do that. It's so easy to move data from one place to the other that you don't need ETL processes anymore, hence zero ETL.
You got it.
There you go, Todd.
I've been paying attention.
Hey, it looks like we have a comment saying it's an interesting topic. I love to hear that everyone else is just as excited about it as we are. I think it'll be pretty great. And so we have two different locations that we're grabbing data from today as we're loading them into Redshift. So maybe do you guys want to kind of tell us a little bit about each of your specific origin locations?
Yes. So I work on Aurora Postgres, which is a fully compatible Postgres engine. And we are able to send data from your operational OLTP workload, which is a structured data set, and get it into Redshift. And we have several exciting capabilities, which we'll talk about in a few minutes.
Awesome.
Yeah, and I work on DynamoDB. So DynamoDB is a NoSQL database, primarily targeted for building applications at scale with very low latency. So you're talking about internet scale applications. Some of these streams that are actually also running on DynamoDB today. So the idea is that a lot of data actually lives in DynamoDB, but doing analytics is not primarily the forte of that service. So you would want to have an easy way of doing analytics by these easy to set up integrations. Nobody wants to manage pipelines, so we kind of take care of all of that work behind the scenes to move your data from DynamoDB into a more structured analytics optimized format in Redshift, so you can do your analysis, run machine learning models, etc.
Okay, got it. So we've got three different places that data might be sitting as we're talking about today. We have Aurora, which is going to be structured data, that Postgres data that you'll be talking about. We have DynamoDB, which you mentioned is kind of internet scale data. And then we're going to be showing two different ways to feed that data into Redshift, which is more large scale and for data analytics.
Exactly.
Yeah, that's going to be my question. So why would I want to do that? Why would I not just run analytics off my source databases? Why would I want to move that data to Redshift?
Because it takes a lot of your compute overhead. So imagine if you are serving peak, if you were Netflix and you were serving shows at the peak of evening, and you wanted to also know, hey, like Todd is watching Netflix, but I also want to know what else can I recommend to him. You don't want to bombard your database, which is storing that data, to know, hey, like what is my personalization for Todd, right? And at the same time, mapping this or doing this in an OLTP database such as Aurora or DynamoDB, it is not optimized for analytical purposes, like Shazab was mentioning. So you need to have certain machine learning models, certain integrations around data masking or creating a materialized view, which helps you do this better in an analytics system such as Redshift. Another one is, we are only talking about two. We have multiple integrations. So we also support this for Aurora MySQL and RDS for MySQL. So imagine if you had like 15 different sources, you can't individually run it in those sources. You need to get it in a central data lake type setting.
I see. So as you were explaining that, I was thinking like well-architected. This is how I get closer to a well-architected workloads where I am not, I can think about the operational efficiency and the performance and the scalability of my data so that I'm not just overkilling my services or degrading some experience in some other aspect of what I'm delivering. That's really cool. So you're going to show us today, what exactly are you going to show us today? You're going to show us how easy this is to do?
We will show you, both of us will show you how in few clicks you can take away the overhead of doing something similar in days or sometime in months. And we'll try to see how quickly both of us can do it.
Okay. Yeah. So before we get into it, we got some people coming in. We're live. We're going to try to field some questions. We have a question coming into the chat right now. I'm just noticing it. Judy Levi, I think is the name. A great addition to Aurora PostgreSQL. Do you support JSON B data type to Redshift super data type? So it looks like some data type conversion question.
Yes. So in general, we are able to map your data types automatically from Aurora Postgres into Redshift. JSON-B is one of the things which we are working on support for, and it should be available in the next release.
Okay, cool. So I think you guys...
What's like?
We say demo time. We need to have like a song that plays every time. We're like, demo time.
Demo time.
Okay, let's bring that demo up.
No pressure. No pressure. So
All right, so Omnav, you'll get us started.
Yes, so we'll start with the Aurora Postgres integration. So I just have another screen. Fiona and Todd, I still have your full attention. So I'm just going to show you where we are starting. So we are starting on the very familiar RDS console page, right? And for you to create any integration, you just go to this pane on the left side, which says zero-ETL integration. And this essentially shows you step by step the three main steps. Don't get overwhelmed. We will handle it for you. It essentially is trying to get your Aurora Postgres database ready first. Then it is letting you select your Redshift data warehouse. And finally, you just click a create button and your integration is created. So let's try to create an integration. So because this is an AWS OnAir show, we will try to create an AWS OnAir demo. And we will try to move on with a quick description. And here, now we are going to select a RDS database, which is an Aurora Postgres. So I have
what kind of data do you have in this database?
Yes, so we have some ticket reservation data in this. So this already holds like some data around users, events, some date, and that we will see how it shows up in the Redshift side. So I already have an Aurora Postgres database engine here, and it is running on version 16.4. So remember 16.4, you need to be on there. And then 16.4. So then we select it.
I'm seeing a fixed parameter values pop up here.
Yes. So good catch, Fiona. I thought you will skip it. So this is, like I said, you need to get your database ready to send data. And for that, you need to set up some parameter groups, mainly around what we call as enhanced logical replication, which is our innovation to Todd's question, why don't you want to do it on OLTP side? We make it faster by having a dedicated storage layer. So all of those settings would be set up for you. And all I need to do is just do this fix it for me button. And this will require your reboot. So Todd, don't do it when you're watching Netflix show. Do it when the database is not busy. Then we just are going to cherry pick certain databases and schema. And how I do this is I'm just going to specify a filter here. So what I'm doing here is for the Postgres users here is I'm selecting a database and then I'm doing wildcards, which essentially will pick every schema and every table within that database. And then for the second database, I'm going to just pick schema 1 and all the tables for schema 1, right? But then that is for including, right? But what if I also want to exclude certain things, right? You don't want to say send out your personal data or a social security data. So I'm just going to add like a table here, which is date. Next, I go to, it is going to ask for my permission. So I'm just going to confirm that I'm okay to reboot my cluster. Now it asks me for my Redshift data warehouse. So let's select one here.
And so I have where we're sending it to.
Yes, this is the point A and this is the point B. So we did the point A. Now we are talking about point B.
I see another pop-up.
Yes.
Yeah, you can't get anything past Fiona Abhinav. I don't know. She doesn't
Okay.
miss a P on
I
the
see a
plate.
pop-up.
Clearly like Hawkeyes. So what we are seeing here is that it is asking us for permission that we don't have the required Redshift principal setup on that database house. And then we also don't have the case sensitivity setup, right? Don't worry, no sweat. We will just again select fix it for me. When in doubt, Fiona, just select fix it for me. And we'll figure it out. Then we just again give a acceptance. It will show you a summary of what we are changing, a quick summary if you want to add optional tag and encryption settings. By the way, everything is end-to-end encrypted all the time. So we have end-to-end encryption both in transit as well as REST. But this is if you want to provide your own key, because some of our customers do that. And finally, we get to this fancy screen, which shows you a summary that this is the integration we are creating. This is the source, which we selected. These are the filters, which we set up. And then these are the parameter changes, which the integration will make for you, the 4, which we need to. And then finally, we have the target here, which is the point B. And then we have the parameter settings around case sensitivity. And then I need to just select on this create zero-ETL integration.
All right. And so how long does it take to get from Aurora to Redshift?
So it will take, depending on your dataset size, this can take anywhere from few minutes to maybe like half an hour in general. But we don't have half an hour. So I thought ahead. We do have something already set up. So let's see already set up integration. So we will go to my dashboard, and this is an integration which is already set up, similar to before. And you can see those same filters, Fiona, if you remember, Hawkeye. So this is the same filter.
16.4. I remember that too.
Yes. So we have that. So let's see how this shows up in Redshift, right? So let's go to a Redshift console now. And we go to the zero-ETL integration tab, similar to before. And then we click on this tab real quick. And this shows up here. And let's just quickly run a query here. So if you remember what we sent here, I'm just going to show it. So you have a demo here. Your schema 1 showed up here. Right, so you have your 7 tables, and then let's look at demo DB2. So we only sent schema 1 here. So if you remember, there should be 6 tables, and then 1 table is excluded. Now let's just quickly show how we can pull the data. So this is a very simple query, which you can see here. But Fiona, you might be wondering, Abhinav, so how quickly does this happen? How much time?
How did you know? That's what I was wondering. That was exactly what I was wondering.
How much time do you think it will take if I made a change on the Aurora site file to show up here? Just a guess.
Let's say an hour.
Okay, let's challenge that.
1 hour.
Well, we don't have an hour. So Fiona, I have a challenge for you. Why don't you take out your phone with a timer on? And when I say go, you go.
This whole thing?
Okay? Yes.
All right.
Right? So just a quick check. We have John here staying in San Francisco, which is in California. So what we are going to do is relocate John from San Francisco to New York. Okay. I'll also show you. I'll tell you. So right now in Aurora, it's showing in San Francisco. Let's send him to New York. And when I say go, you go. Okay.
I'm locked in and ready.
1, 2, 3, go. Okay. So I have executed the query. Now let's go to Redshift. It's still showing in San Francisco. And let's refresh. And how much time? Stop. So it was under 9 when I said stop.
Okay. I was a little delayed.
No. Hey, so wait, time out. Let me recap something here real quick. We started with data in Postgres.
Yes.
And we set up an ETL from Postgres to Redshift. You're now querying in Redshift. And what you're suggesting is from the time you changed it in Aurora over here, the source, the time it zero-ETL'd into the destination, less than 10 seconds.
Yes. And what better? We do this for 24 million operations within 10 seconds.
That's amazing.
So we are able to do something similar. And just to prove what I was saying, this is our end-to-end replication lag, and it was 2 seconds. So the time which you saw as 10 was more around just me switching between windows. So it's actually 2 seconds which it took for it to replicate. But I know Shazab also wants to show us some fun. So Shazab, why don't you show us the DynamoDB side?
Like 2 peas in a pod. We are up next on DynamoDB. Let's bring it, Shazab. Let's see what you got.
Yeah. So I'm gonna quickly walk through the DynamoDB side of the demo. So similar to what Abhinav was talking about, the idea of zero-ETL setup is very similar. Like we want to make sure it's a few clicks. So I'm in the DynamoDB dashboard. I have a table. I've already imported some data from the stock market. It's easy to understand. So on the DynamoDB console, we have a new integration section. So similar concept, we will prepare the data. The data is going to be sent to the target service, and then you can just do the querying on the target service. So I go to the create integration section, and then I click on Redshift. By the way, DynamoDB has another integration, which is OpenSearch, which has been out for a while. So this is a new offering that we just launched recently. So when I click on create a Redshift integration, you would see a very similar walkthrough of how to create an integration. So I'm going to call this AWS OnAir. Any description?
Hey, you want to bet that underscore is going to give you a problem?
Ooh.
Oh, Hawkeye now.
Hawkeye.
It's fine.
There you go. You guys are paying attention. All right. So, and then I'm going to browse the DynamoDB table. So I'm going to click on the stocks import table and then click next. And
I
then,
see a call out.
there you go.
I
So
had my
one of the
carrots
things.
this morning. My vision's incredible.
We need to have
There
a
you
fix it for me button across all of AWS. That's amazing. Just
I
fix
like
it.
that.
I like this new pattern as well. So basically, one of the things that we do on the DynamoDB side differently is that we actually want to make sure that it has no impact on your production tables. So we use exports, which are always isolated from your production traffic. So, if you're running large internet scale applications, this process is going to have no impact on that. So for that, you need to enable point-in-time recovery, which is another feature of DynamoDB, and we apply some permissions on the resource policy directly for you. So you click Fix It for me, and then you go to the next page where you're selecting your target warehouse. So I've been using serverless. So Redshift, you can use either a provision cluster or serverless. It depends on what fits your use case. Serverless is just easier for me to set up. So I select the serverless Redshift cluster. Again, we have some optional parameters that you can put in there. You can tag it, and also it's always end-to-end encrypted. But if you want to change the encryption, you have the option to do that here.
Okay.
Then click Next, and then it'll give you a confirmation screen of just reviewing your details. One thing that is different from Aurora is that in DynamoDB, you don't have a concept of databases. It's just tables. So you just have tables, and we're replicating one table into the Redshift. So I'm going to click on Create the DynamoDB integration. And because the initial setup does a full export of DynamoDB, it depends on how large your table is. It can take between depending on your the size of the table, it may take a few hours to a few minutes. So I already have another integration setup, which I'll show you how that looks like. So once you have that set up, you can go to the integrations details page. You will see the status as active, and you will see the database state as active as well.
I just want to quickly call out that we had a hilarious comment from Robert Tables that said, "Tables, you say?" That was funny.
That was great.
Okay, sorry, continue.
One more step that I actually wanted to show. So when you're creating the integration, you also have to attach a Redshift database. So as you're going through the step, we actually walk you through it. It's as simple as just clicking here. I'm going to put this as AWS OnAir. Click Create Database. And then it'll start. Yep, you'll see the database state as creating. So give this a few minutes. We'll let that one run, but I'll come back to the one that I created earlier. Your database state is active. On this page, you can see some statistics. So on the DynamoDB side, because we're using exports, the lag is not as flashy as what Abhinav was showing us. So we're talking about around 15 to 30 minutes. So the use cases that we want to serve on this side are more of aggregated analytics or business intelligence use cases. We're not primarily targeting operational analytics. So within 15 to 30 minutes, you'll see the data as it shows up in DynamoDB.
Probably not going to time that one right now.
Do we have that much time on the show?
Minutes left, Azev. So I want to make sure you get to everything you want to get to.
Yep, absolutely. Okay, so now the fun part. So I think once your data lands in your Redshift cluster, I've already set up some queries just to kind of show you what it looks like. Oops, my connection is closed. Let me just quickly.
Happens real time. You got to refresh that connection.
Which
Yeah.
demo?
I just want to
Which
confirm
demo?
some. We had a comment in here that wanted us to confirm that this concept works for Redshift serverless as well, and I think that's what you were showing, right? You spun up a serverless Redshift instance, and that's where you were moving data to, and that's what we're querying now.
That is correct. Yes, you can do it on a provision cluster as well, but serverless is the new. I would say it's easy to set up for.
Sure.
So the way that the data shows up, because DynamoDB is semi-structured, we have a partition key as one column. Your second column is a sort key, and your third column is a JSON super column type, right? So it has all the other data that is sitting in DynamoDB. So the way you want to query this is, so I created a query where I'm looking at all the highs for the different stock tickers for a day. Gotta refresh this again. There you go.
There we go.
So this returns all of the, it's parsing through the JSON super column type, and it's returning all of the highs for each individual stock for a particular day. So it's very suitable for you to do ad hoc querying. You don't have to rely on DynamoDB. DynamoDB can take care of your operational application workload, and then on the side, you can enable your data engineers or all the analysts to just go at it without impacting your DynamoDB workload.
Yeah, so you mentioned something. So there's a little bit of you have to go from semi-structured to structured, and then understand the differences in querying. I know with DynamoDB, we're talking sort keys and partition keys, and then over here, we're talking something different. So, but what you just saw, I want to call out is like how fast you can query this data, especially when you have large amounts of data coming in here, how fast Redshift's going to perform in these types of aggregate or complex queries is pretty cool.
Yeah. Redshift is primarily built for these type of workloads, right? So you can leverage the power of Redshift's querying capabilities to do advanced analytics and machine learning. So you would offload all of those workloads on Redshift and make sure that you're enabling that side of your business without impacting anything on your operational side on DynamoDB.
We've got some questions coming in here. This is some good audience interaction. Another question from our audience, Lorenz, I think it's how you say this, Lorenz with a 3.
That's right. Mm-hmm.
Wants to know if you support SAP HANA as a source.
Yeah, so I can take this. So essentially, we are also working on several third-party sources as well. And we are looking at some of the third-party sources as well. I can't confirm yet, but we are looking at several key platforms which people might be using. So stay tuned.
Stay tuned.
Stay tuned. Watch the space. There's a lot more coming.
Keep watching AWS OnAir. Maybe they'll be back.
And have a fix it for me button when I know. Cool. Hey, I want to make sure if there's anything else you guys want to show us. If not, where can our audience go to learn more about zero-ETL, about Redshift and these features? What should they do next?
We have dedicated pages on the AWS website, and we also published several blogs this week. So both these integrations went live on 15th, which is 3 days back. So all of those resources would be available to folks. Please check out and give us all your valuable feedback, especially to Hawkeye, Fiona, and Todd.
Yeah, hey, thanks for coming on the show, Abhinav and Shahzab and Fiona. I'm impressed with your ability to catch those red flags.
It's what I'm here for. That's the only reason they bring me on.
And she's cool as a cucumber.
Oh, thank you. That's too nice.
Hey, thanks, guys. We'll see ya.